Yeah.
So generally speaking, predictive maintenance is supposed to be, that's one that's more common. But prescriptive maintenance is not so common, but that's like the sweet spot. That's where you get to use AI to sort of detect anomalies in the system and try to also suggest ways to improve the system or things to adjust the machine just to avoid that failure from happening.
Hi everyone, my name's Lara Blythe. I'm a teaching fellow in the Centre of Excellence for Data Science, AI and Modelling. And this is Namdi, and I'll let Namdi introduce himself.
All right, yeah, thanks Lara. My name is Rafi Namdi Ochuba. I prefer to be called Namdi. All right, so I just recently completed my program, my MSc program at University of Hull.
Okay.
Yeah.
Super. Right, so first question, can you give us a brief overview of your project and of your final project and its objectives?
Yeah, sure. So my final project was on assessing data-driven models for predictive and prescriptive maintenance of safety critical systems.
Okay.
Basically, so I used the NASA turbofan jet engine as my case study.
Yeah.
Yeah. So basically, the objective of the project was to assess various models to be able to predict which metrics are going to have the highest influence on the remaining useful life of a NASA turbofan jet engine.
Okay.
Right. So we also got to dabble into other things, but one of the things was how you can use check different models.
Keep going. Okay, so next question. What inspired you to choose this project topic?
Okay, yeah, so basically, one of the things that inspired me to choose the project, I watched a movie called Hidden Figures. The movie called Hidden Figures is a movie where it was like a real life story of how computational precision meant the difference between life and death in NASA. Right, so
okay, so
yeah, so that was one of the things. And as an engineer, safety is very important to me. I have a background in engineering.
Right. Okay.
Yeah, so safety is something that I'm very concerned about.
Yep.
Particularly in aviation, and also as someone that is an entrepreneur, I'm also an entrepreneur. So I'm also concerned about the business aspect of it.
Yeah.
Because for two reasons. One, safety, for you to ensure safety in any industrial application, it just means that you are doing something that is of high importance. And secondly, when there's an unplanned downtime in any system, particularly in aviation, it leads to a lot of economic issues, because yes, for the period that the machine is down, you can't make money.
Financial impact is pretty high.
Yeah, for all of those reasons, that was one that inspired me.
Super. So I consult my list of questions. So what specific techniques did you use in your project, and why did you choose those techniques?
Okay, so basically, going back to the objective of the project, I'm trying to assess various data-driven models. So I tried to use both the traditional machine learning models and the deep learning models as well. So the traditional machine learning models, I had 3 traditional machine learning models and 3 deep learning models. The idea was to be able to check which of them would be able to which of them would have the best results for this specific case.
Okay.
Of course, later on we can try to apply some kind of transfer learning to see how we can transfer the training of this data to other applications, right? But the idea was try traditional models, try deep learning models, see which one works better, and then we take it from there. Yeah.
Super.
And then I also developed a classification system.
Right.
So basically, two major things that happened. One is we tried to use those various models, both traditional and the deep learning models, to predict the remaining useful life of the equipment. That just tells you how long the equipment has until it fails.
Right. Okay.
And then we also try to do a classification application such that we can tell we can not just telling you how long the equipment has. We also give you some kind of visual cues or using classification to tell you the equipment is currently in the high risk zone, or in the medium risk zone, or in the low risk zone. So
you don't need to worry about the low risk zone for the moment, at least.
Exactly. So when you see it's in low risk, okay, you still have some time before it fails.
Yeah.
Once you see it gets into the medium or high risk, then you have to be concerned and think of how
start doing something about it.
Exactly.
Yeah.
So generally speaking, predictive maintenance is supposed to be that's one that's more common. But prescriptive maintenance is not so common. But that's like the sweet spot. That's where you get to use AI to sort of detect anomalies in the system and try to also suggest ways to improve the system or things to adjust the machine just to avoid that failure from occurring.
Right, okay, super. So did you face any challenges during your research?
Yeah, I faced a couple of challenges.
So how did you overcome these?
So initially, first of all, it's a project that involves a lot of research because of the particular area I delved into. So one of the key challenges was time constraints. So I could have the data set I used had four different sets, so to say. So some of them had fewer parameters than others, but of course the ones that have more parameters are more closely related to real world systems. So but I had to start with the simplest version and then build up to the more complex ones. So I think that one of the major challenges was time, but then after I was done with the project, I've gone on to spend some extra time to see how I can improve on the previous ones. Then another challenge I had was also computational power, but of course that is something that DAME provides for. I'm using the Viper.
You used Viper, did you? Oh, brilliant. Okay.
I didn't use Viper initially because I was thinking I could use like the free tier GPUs on Google Colab.
Right.
But then at some point I realized that like if I had used Viper, I would have been a lot more efficient. But by then I had already gone too far in. So I'm sure if I'm doing it, if I'm trying to improve on it going forward, I would definitely use Viper to try to improve the speed of my computations. Yeah.
Super.
Because,
no, that's brilliant.
One of the major challenges again was because of the amount of computational power I had available to me, I couldn't do enough hyperparameter tuning for the models. So I had some pretty good accuracy levels, but I think it could have been much better if I
with
had
that hyperparameter tuning, right?
Yeah.
Okay. So, how do you see this project evolving or being applied in the future?
Hi, my name is Kevin Pimblett, and I'm the Director of the Centre of Excellence for Data Science, Artificial Intelligence and Modelling, otherwise known as DAME, here at the University of Hull. We run an MSc conversion course in Artificial Intelligence and Data Science here at the University of Hull. A conversion course takes in students from a wide variety of different backgrounds, not just STEM subjects, but arts and humanities and everything else in between. We upskill them in data science and artificial intelligence, and we do that through a series of bespoke modules, starting with Python programming in the first few weeks of trimester, leading into introductory materials in understanding artificial intelligence and the fundamentals of data science. We've just built a new building that you can see all around me. This is a £4.5 million investment by the University of Hull and a strategic decision to invest in artificial intelligence and data science for the long term. Here at the University of Hull, we offer the full breadth of artificial intelligence and data science. We have elective options in a range of different subjects, from ethics right through to AI in healthcare and a lot of others in between as well. We like to have our students on campus for one full day per week. That's from 9 AM right through to 6 PM. What this enables is for our students to manage their own time, so that if they have a job for which they might be going part-time, they can do it for the rest of the week, and therefore they can have that full day on campus learning and doing all the programming that they're required to do. There are a variety of reasons why our students choose the University of Hull as their first choice for an MSc conversion course. Not only do we upskill our students within the areas of AI and data science, but also locally this is one of the best regions in which to study. Here at the University of Hull, we offer the widest variety of different training courses in AI and data science. We also offer bursaries that our students are able to apply for, so if you are female, black, disabled, or from a low socioeconomic background, as might be judged from the higher rate of student loan, and you are a UK citizen, resident, or settled status, then please do consider joining us.